Okay, so we have the definition of absolute value. We have the modulus of x is equal to, and then we have a definition. We've got x if x is greater than or equal to 0, and minus x if x is less than 0. So what that means is modulus here, or absolute value, just means make it positive. It's a magnitude, it's talking about length. So it'll start pretty easy. We have x equals minus 2, find the modulus of x. This means find the modulus of minus 2. What's the size of it? 2. Okay? If you put the minus 2 in there, and you make it positive. Maybe I can demonstrate how we apply it, right? What's going on here is we're going to have the modulus of minus 2. And up here we've got the definition. It equals minus x if x is less than 0. So because x is minus 2, we're putting in there the value minus 2, which becomes positive 2. That's what's going on with the definition. Okay, next one, we have the modulus of x take 5. All right, so we would have the modulus of minus 2 take 5, the modulus of minus 7, and all we do is make it positive. That gives us positive 7. C. Modulus of 2x plus 10, so we substitute in the minus 2. We have the modulus of 6, and the modulus of 6 will just be positive 6. And then for D, we have the 3 take the modulus of x. And so this will be 3 take the modulus of minus 2, 3 take, now the modulus of minus 2 is 2, so we have 3 take 2, and our result is 1. Okay, so all you're doing in the first part here is applying absolute value. Okay with that? Yeah, cool. Okay, so then let's look at define the following algebraically and graph. Okay, I told a lie, there's a little bit of graph. All right, so the first one we have is y equals the modulus of x plus 3. Now, all I'm doing for the definition is I'm taking this statement of modulus. This is very important. This is going to pop up everywhere. The modulus of x. So, this is going to be, this is how we'll define it. Modulus of x plus 3. It's going to equal x plus 3 if x plus 3 is greater than 0. Okay, we'll solve that inequality. Now remember, the rules for inequalities are the same as an equation unless you multiply or divide by a negative. The direction of the inequality will flip. We're not doing that. We're just subtracting 3 from both sides, so the inequality maintains its direction. That inequality simplifies to that. And then it'll be minus x plus 3 if x plus 3 is less than 0, which means x is less than minus 3. Now I'm going to restate this again, just so it's a little bit clearer about what's going on. Okay, so then for us to sketch this, we can use our calculators, but here's what's going on the Cartesian plane. Our value for the domain is minus 3, so I'll put that in here. We have minus 1, minus 2, minus 3. Now, the line, okay, look at this definition. The function is x plus 3 for x is greater than minus 3. So that means when x is larger than minus 3, we've got to graph the line x plus 3. Okay, let's do that. That's the equation of a line. It has a slope of 1, which means as x goes across 1, y goes up 1, and it has a y-intercept of 3. Okay, x plus 3 has a y-intercept of 3. So I'm going to sketch that part of it there. Okay, that's the first part of it, x plus 3. But then for the second part, it says if x is less than minus 3, this is the function that we graph. Minus x, take away 3. All right, still the equation of a line, but this time it has negative slope. Okay, so that would mean as x goes across 1, y goes down 1. Furthermore, this line has a slope of minus 3. Now, what I'll do, it would be a line going like this. I'm going to put it dotted, and then saying that it exists here. All right? Across 1, down 1, across 1, down 1, negative slope, right? Y-intercept of minus 3. So let's put the dot so we can say minus x take 3, and up here y equals x plus 3. However, remember, what are we graphing here? We're graphing the equation, the modulus of x plus 3. All right, and so if you graph that on your calculator, this is what it's going to look like, because it takes every negative value and makes it positive. Here we would have negative values, and so what's it doing? Making them positive. The other way to think about it is exactly like that. If you continue this line the whole way down, all that's happening is it's flipping up there. All right, make those negative values positive. That's what modulus does. Okay, is everyone happy with how I've generated a graph of this absolute value function? Yep, if you type in, do we know how to type in absolute value in our calculator? No, I'll show you quickly. So you press so if we go to graph mode and we go option numeric, okay, and we can see absolute. So option, when you're in graph mode, you know, select option numeric, and then we can select absolute. All right, I think we will pause there, and I'll get you to start on this exercise.
It's not showing any negative values.
Yeah, we don't expect it to. All right, what we expect it to do, because what does absolute do? Absolute makes it positive. So that's right, Jack?
Mm-hmm.
You happy with that? Yep. That's all it's going to do, is make it all positive. Yeah, so we'll stop there. We'll have a go at 3F.1.